In this example, we're going to be looking at a problem involving Boyle's Law. And we have a confined gas in a container with a volume of 3.43 liters and a pressure of 2.65 atmospheres. And we want to know what's the pressure of the gas if we move it to a container with a volume of 1.25 liters. So we need to identify our variables in Boyle's Law. And so P1 will be our starting pressure. And if we go back and look at our problem, our starting pressure is 2.65 atmospheres. And our starting volume, we can go back to our problem and look, and our starting volume is 3.43 liters. Our pressure 2 is what we'd like to find out. And volume 2 will be the volume after we move it to the second container. And that second container has a volume of 1.25 liters. So now that we've defined all of our terms, it's simply a matter of substituting in variables and solving for the one that's missing. So we'll be solving for P2 in this case. So we can rearrange Boyle's Law to be P1 V1 over V2 to give us our pressure at the end. So this will be 2.65 atmospheres times 3.43 liters all over 1.25 liters. Notice that our units of liters will cancel and I'm left with a unit for pressure, which is good because I'm solving for pressure. So we'll go to our calculator now and plug everything in. 2.65 times 3.43. All of that will be over 1.25. And we find out that our final pressure is going to be equal to 7.27 atmospheres. Rewrite the unit a little more clearly. 7.27 atmospheres. And this makes sense because the volume of our container got smaller, so our pressure needs to increase.